So we will now move into section 2 of our workshop, and this will be on power, propulsion, fuel, and lubricants. Our next speaker is Dr. Michael Carter, Director of the Office of Environment, U.S. Maritime Administration. The title of his presentation is Maritime Environmental and Technical Assistance, Supporting Maritime Environmental Innovation. Michael Carter is the Director of the Office of Environment at the Maritime Administration. He served in that capacity since 1995, when the office was first established. Before then, he was in private environmental law practice. In addition to overseeing MARAD's own environmental compliance, Mr. Carter is responsible for the agency's interface with the maritime transportation sector and maritime stakeholders on environmental issues. That effort includes working with the regulatory and resources agencies at all levels of government, as well as the private sector, academia, and NGOs to drive economic and technologically feasible methods to improve environmental sustainability. A cornerstone of these efforts is the Maritime Environmental and Technical Assistance Program, which he will talk more about today. Dr. Carter.
Well, thank you very much. I'm not sure how I got slotted after Greg. I think I have to get back down to earth here, so I think I may take a minute or two. Anyway, as mentioned, I've been with MARAD for about 20 years, a little over 20 years. Started off with the Office of Environment and found basically that we didn't have much going on in the Office of Environment. It was first created mostly to deal with our environmental compliance. We've just gotten hit with a bunch of fines and penalties by EPA because we happened to operate ships, and many of those were coming back from various wars and stored chemicals on board rather than get rid of the chemicals. So that's kind of where it started out. That was the bread and butter to begin with. But the real function of my office, at least the part I really enjoy, is the Maritime Industry Stakeholder Assistance. I began with shipyards, ports, trying to do things with them, things like best management practices, things I could do without any money. But we deal with vessel owners and operators, ports, shipyard, federal, state, and local environmental, regulatory and resource agencies, and we're trying more and more to be more tuned into some of the public issues. So we'll talk a little bit about that. About 10 years ago, we kind of looked at what MARAD could be doing in this area of technology assistance or assistance to the industry. And basically, we looked through and I talked to my staff. I said, what are we looking at here? One of the problems is we were seriously lagging behind landside transportation. Hundreds of millions of dollars were being put towards innovation on the land side, whether it be electric cars, fuel cells, alternative fuels. And there was really nothing much from the public sector going into the maritime world. Really with ballast water, we also identified that nobody knew what technologies could do. And many of the technologies that people were espousing as possible for ballast water were landside treatments that you can't just take and put on a ship. It doesn't fit. There are other concerns, chemicals, introducing chemicals into engine rooms, things like that. So we looked at it and said, well, we really need to show our industry that these things can work. So we need to look for demonstration and innovation in things like alternative fuels. We had heard on the biofuel side, you can't use the ethanol. It gums up the engines. It doesn't work in cold weather climates because it gels, that kind of thing. So we needed to look at that. And then energy efficiency and conservation, another big issue that we were looking at with the maritime sector. So out of that was born what we call the Maritime Environmental and Technical Assistance Program. It was first got funding in 2010 from the Hill We finally got it in a budget, and we finally actually have the authorization language, which happened in 2012. But our objectives were to try to stimulate the technology to improve sustainability. A lot had not been done, whether it was domestic or internationally with this, from at least our perspective. And then the biggest thing was collaboration with federal, state, local agencies, on and on. What we found was Navy was doing stuff, NOAA was doing stuff, we look around, Coast Guard was doing something, but nobody was talking to one another. So that was really kind of a big part of what we tried to do, and so we've developed this collaboration among all those agencies, and I know I'll miss somebody, but as we go through, we have partnerships with all of those folks. So these are the areas that we've been focusing on for the last couple of years. Natural gas, we'll talk about that later because they really wanted to talk about fuel cells here. We are not ignoring solar and wind, but for the kind of bigger merchant type vessels, this is something that we've got to look at harder and will take a lot more time to get to. Hybrid propulsion, we already have some hybrid tugs. Out in California, Foss has a hybrid tug. We've done some work with them on that. And then exhaust gas treatment, and then ballast water. Ballast water, as I said, was where we started. Ballast water and hull fouling, obviously very big issues for our marine environments. I don't take credit for these transitions, they're not my thing. So let's talk about the fuel cells. In about 2012, we were approached by DOE. They knew we were doing things in alternative fuels and energy, and they said, you know, we really want to see if there's a maritime market, or a market in the maritime segment for fuel cells. We don't know what it's about. Can you work with us to try to see what might happen? And we're talking about not only just with ships, but with port equipment. Your yard hustlers, your cranes, all those kind of things, shore power, what have you. Some of the key issues that have cropped up or that we knew about when we went into it, things like size, weight, how much power, how big were the fuel cells, how much power could we get out of it. The cost, of course, is huge. So that's a big issue. Power integration and regulation. You know, the ships operate on a bunch of different voltages and power requirements, and fuel cells don't necessarily adapt well to changing loads, that kind of thing. Hydrogen, what's the source of hydrogen? Are we going to use pure hydrogen, which has its own issues aboard a vessel? Are we going to look at using other fuels and doing a reformation of that fuel? And then let's talk a little bit about the biogas. I mean, we saw some slides on that. And then, of course, the issues of safety and fuel storage. This was our first foray into fuel cells. We worked with Sandia Laboratory, Hawaiian Ports, Young Brothers, and the Navy to build a fuel cell within a 20-foot container. That container then provides enough power for 10 reefer containers, so you're replacing the generator sets on those, the diesel generator sets, with a fuel cell, 200 reefer hours. That was the goal. It's still being tested, but so far things have looked very good, and Young Brothers is actually using it on board some of their tug tows that are going between the Hawaiian Islands. The next step is Navy's going to be taking it on and doing some work with it in some of their exercises this summer. And then we have this nice fuel cell that we would like to bring to the States, and to the States, look at California, look at inland waterway, maybe put it on some barge operations there and give it some more workout. Some of the other stuff. This next one is the shipboard technology demonstration of fuel cell for auxiliary power. Very small fuel cell. Anybody that knows all these things about wattages and voltages knows this is tiny. But it was donated to us from the Navy. And what we decided to look at is how do we reform other fuels so we don't have to load hydrogen. If you already have your GP8, your ultra-low sulfur diesel or number 2 diesel oil, then you have tanks available for it. You don't have to retrofit with other tanks if you can reform that fuel to produce your hydrogen. So that's really the thrust of this project. It's still in the formative stages. We've done some work on the reformation process. The first time through it didn't work very well, so we're working on it some more. This one is kind of exciting, the Zero Emission Ferry. We're partnering again with Sandia Laboratory, Red and White Fleet, and we're basically looking at a design feasibility study for a high-speed ferry and for the fuel station on shore. We're talking about a 150 passenger vessel that goes 35 knots. It's a little bit more about the performance. You've got a 23 nautical mile one-way trip. So you're talking about a fairly good distance, 35 knots, zero emission, 150, 149 passengers, and 1 refueling per day. Notionally, this is kind of what the ship looks like. The fuel cells back in here, this area. Your hydrogen storage is right up in this area. Many challenges to this, including safety zones. So we're working very closely with the Coast Guard and classification societies on trying to get the right design for that. We're pretty open to looking at all sorts of operations with fuel cells. We'd like to get more into the port side. One of the kind of exciting things is that biogas actually can be made at some of the ports, particularly if you've got produce coming through. You know, you've got wastage, you can use that. You can use that to help power your fuel cells. Port applications, more port equipment, as well as for backup power. So we're just starting on this, but it's certainly something that's going along very quickly. Natural gas, I'd mention it. The big drivers here were the ecozone that was talked about earlier today, and people searching for alternatives to ultra-low sulfur diesel, thinking either it wouldn't come out in time, wouldn't be enough, or the cost that would be so high. Because of the change in the oil market, the interest in LNG, of course, has dropped down, but we continue to move forward with that. You'll note we had another partnership with the government agencies, who was doing what to whom, what were the issues that were out there. We started off in 2012 with a feasibility study in the Great Lakes, looking at needed infrastructure, the kind of routes that people were operating. How could we do this up in the Great Lakes? We expanded to the Ohio River and then the lower Mississippi River. Then we got together with the Coast Guard particularly in 2013, talked to them about what we needed to understand about LNG use, both on the shore side and with the vessels. And so we did a study on infrastructure, bunkering, and feasibility. That study has been the basis of a lot of work that's come since then. 2 issues that came up, particularly from the public and from EPA, were the total fuel cycle for LNG. Are we really getting the bang for the buck that we need in here? And you'll see that we are, except with greenhouse gas overall. The methane slip is still an issue, with methane being the kind of greenhouse gas that it is, which is worse than the carbon. What you end up seeing here is that basically sometimes you get a better footprint, sometimes you about break even. So you're now saying, well, is it more important to get to the criteria pollutants or to the climate change stuff? So we're seeing it, and remember this is just kind of one study that was looking at it, but we looked different routes, and so we're seeing some issue related to the greenhouse gas. The methane slip and release study was to look primarily at, knocking over your mic, primarily at the interface with the ship, the fueling at the ship, and then during its use within the ship and engine. It was not looking at the whole supply chain. We wanted to see what could be done in the maritime sector at that interface and with engines to try to improve on methane release and slip. We have a couple of demonstration projects going on right now. We're working with TOTE. What we're trying to really do is get a better picture of what the emissions really look like when you use natural gas, and also what's some of the challenges they face and lessons learned as they go forward. And then we have this tug operation that we're working with the Pittsburgh Region Clean Cities group on. It's a small tug, and they're going to be using a fumigation technology. So you're blending diesel and LNG as it goes into the engine. You won't get all of the benefits, but the idea is, can we see if this would work with tugs to take advantage of some of the benefits without storing lots of LNG on board, and room is a big problem for them. Okay, I mentioned renewable fuels, and it was mentioned this morning. I think there's a speaker that's going to be talking about it more later, so I won't go into a lot of detail. But we did a couple of tests aboard some of our ships. We have school ships, and we looked at blending the new drop-in biodiesels. It's not the ethanol, and blended 50-50, and then we did a 70-30 blend. We did see a pretty considerable reduction of all of those criteria pollutants and what we found also was that that was less than just the pure ultra-low sulfur diesel. So if you use ultra-low sulfur diesel, you didn't get the same reductions as you did with a blended fuel. You also got quieter engine performance. Had no issues with the engines in terms of their material condition or with their ability to operate without incident. Again, there are only 2 tests, so there's more work to be done there, but it's 2 that we were able to demonstrate that it does work. We have a longer term study with Scripps. They've been running it now for probably a year. I have to give Navy a plug. Navy provided us with a lot of the fuel that we've been using, but we hope to have a report out in the not too distant future from Scripps. How long have I gone? Oh, all right. Well, really quickly, I said we got to start with ballast water and invasive species. We have, through the META program, set up or supported 3 facilities for testing ballast water treatment technology. One is in Maryland, in Baltimore. The Maritime Environmental Resources Center, part of University of Maryland, runs that for us. It's this bottom picture, the barge. One of our school ships, the Golden Bear, actually takes the technologies and tests them out in the ocean setting. We have scientific teams that are supported to go out and do the testing aboard ships. It's all according to the Coast Guard and IMO testing standards. Thank you. That's it.